Good morning, my YouTube viewers. It is Crystal here. I just wanted to do another code review for you. This is with Kaggle's community competition, and it's a paper classification. And I spent all day yesterday and some of this morning working on it. And so basically, what it is I scored number 6 out of 6 on the leaderboard, but since it was really difficult, I decided that I'd go ahead and do a code review on it anyway, since I spent so much time on it. So this is your paper classification. Code review is with natural language processing, and I used linear regression model to do it. So I scored at 88%. And I believe that they graded it on root mean squared error, because the lowest score was like 0.07 or something like that. The first time that I submitted this to Kaggle, I got a 3 point something, and I've been able to get the score down to 0.88, which was, still 6 out of 6, but it's better than what it was. And so I just decided I'd spent enough time on it, and so I was just going to let it go, and I'll do my code review. So the problem statement for this competition question is: the goal of this competition is to identify the categories associated to a research paper hosted on ARXIV. Originally, a research paper can have one or more categories associated with it. If so, then you need to predict the list of categories that belongs to that paper. Hence, the problem statement is a multi-label classification problem. So that's your problem statement. So the first thing that we're going to do after we create our program is we want to import our libraries that we're going to use in the program. So we're going to import NumPy as NP, which is a numerical Python library to do numerical computations. We're going to import Pandas as PD, which is a panel data library to do data processing. We're going to import OS, which goes into the operating system. We're also going to use sklearn, which is Python's machine learning library. We're going to import matplotlib.pyplot as PLT, which is a graphics library. And we're going to import Seaborn as SNS, which is also a graphics library, but it has statistical components to it as well. So after we have imported our libraries, then what we're going to do is we're going to use the OS library to go into the operating system and retrieve the 3 CSV files that we're going to be using, which are going to be train, test, and sample submissions. Then we're going to take Pandas, and we're going to read those 3 CSV files in and convert them to data frames, and the 3 data frames are train, test, and submission. So here's your train file, which has your titles, your summaries, your terms, and your IDS. So your IDS is like your index. Here's your test file, which is the titles, summaries, and IDS. It doesn't have terms because terms is going to be what you're going to predict on. And what you'll notice on the terms is it's inside brackets and it's more than one. So what we're going to have to do in the program is we're going to have to take the brackets out, and we're going to have to take the blank spaces out, because that's one of the things that I spent so much time on, was trying to figure out how I was going to do this. So I removed the I removed the brackets, and then I found out that there were some blank spaces in there. So I had to remove the blank spaces as well, and I had to do all that so I could make the target like the target in the submission file. So it wasn't an easy task. Here's your test file, which doesn't have your terms in it. And this is your submission file, and this is what Kaggle wants to see when you submit your data to them. So what they want is, rather than one column with all of the different classifications housed in that one column, what they want it like similar to one-hot encoding, whereas each classification has one column of data. So submission has 61 columns of data, including the IDS. And if you take the IDS out, it has 60 columns of data. So we're going to analyze our train. You can see that when we analyze the train, that all of the columns of data are object columns. We're going to check for null values. The titles, you have 712 null values, and the summaries, you have 338 null values. So what we're going to do is we're going to drop the row where summary is a null value. We're not going to worry about the title so much, but where the summary is a null value, we're going to drop the value, drop the row. Now what we're going to do is we put the terms on a histogram, and you can see this is the histogram, what the histogram looks like. So you've got 60 different categories to choose from. So now we check value counts, and you can see the lowest value is 3, so we don't have to worry about deleting the rows where you have only one value. And now what we have to do is we have to remove a lot of characters from the terms. So we remove the square brackets, we remove the quotation marks, and then we remove the blank spaces. And so when we removed all of that, and then after that, what we have to do is we have to convert the string to a list. So train terms equals train terms dot string dot strip brackets dot string dot split comma, and then we're going to convert it to a series because it was originally a list. So we're going to convert this to a series. And this is what it looks like when we have removed all of the characters. We've converted it to a list, and we've converted the list to a series. So now what we're going to do is we're going to one-hot encode the label. So we're going to use sklearn.preprocessing import multi-label binarizer. MLB equals multi-label binarizer. Target terms equals pd.dataframe. MLB.FitTransform. Train terms. Columns equals MLB.classes. Index equals index train. And you come over here on target terms, and we have 60 columns, which is what we want. And fortunately, it's in numeric order already, so that's good. We didn't have to worry about that. So now what we're going to do is we're going to get the unique values from the list. You can see that there are 60 unique values, and we're going to put it in a set because we want to make sure that the one-hot encoded from the multi-label binarizer has 60 columns, and so you want to make sure that there's actually 60 unique values. Okay, so your label equals your submission. IDS equals submission brackets IDS. And then we label drop IDS, axis equals 1, in place equals true. So we drop that column because IDS is an index, and you don't really need the index. And the reason why is because every row is indexed already. So we check the columns in target terms, and then we check the columns in label. And that's how I figured out that there was a quotation mark and extra spaces in it. And the quotation marks and the extra spaces meant that there were more columns in target terms than there were in labels. So that's why I had to remove all of that from the string of data to get it to be the same. And it was not an easy task. I had to do a lot of research to do that. So now what we're going to do is we're going to combine our train and our test. So target equals target terms, combi equals train dot terms, comma axis equals 1 dot append test. And so you can see now we've got combi, which is titles, summaries, and IDs. We check for blank values, and in combi we've got 704 titles that are null values, but we're not going to worry about that because we're not going to use it anyway. So we're going to process the summaries. So combi summaries equals combi summaries dot as type string. Summaries equals combi summaries. Count words equals summaries dot string dot find all. Brackets are brackets backslash w plus brackets dot string dot len, and you print word counts, and you have 8,553,060 words. And now we have to further process the words, and this took a long time to do it. And the reason why it took a long time to do it is because it takes a long time to limitize the words. So when you stem a word, you just break it out, you just shorten it. But when you limitize the word, you limitize it to the root. So we import our libraries. We import NLTK, that's Natural Language Toolkit. We import stop words. We import re, which is like a string processing library, and we import Porter Stemmer and WordNet Limitizer from Natural Language Toolkit as well. Set our stop words to English. Stemmer equals Porter Stemmer. Limitizer equals WordNet Limitizer. And if you don't want to use Porter Stemmer, you can always use Snowball Stemmer, because that's another stemmer that I found out about, but I'm just sticking with Porter Stemmer for simplicity. So we clean our tweets. So we do that by we convert the summaries all to lowercase. And then after that, we put the summaries into the stemmer by using lambda, which is a single line function that doesn't have a name. And then we limitize the text using the same process that we used for the stemmer. And then what we do is we remove special characters from the text, remove hashtags from the text. We remove words less than 3 characters and greater than 7 from the text. Remove the stop words, and then we count the words after we've done all that, removed all those words. We have 4,520,946 words we have to process. And now what we're going to do is we're going to remove the rare words. So I inserted code to remove the rare words. And then after we've done all that, then our data has been pretty much pre-processed to a certain extent. And then we define our X and our Y variables. So Y is your target, X is your summaries, 0 row to the length of train. X test is your summaries, the length of train all the way to the end. We check our shape, and you see that X is 41,728. and your X test is 5586, and your shape is 41,728 by 60 columns. Now we're going to use sklearn to split our training set up into training and validation sets. And now what we're going to do is we're going to convert the text to frequency word vectors to Tfidf. So we import sklearn's Tfidf Vectorizer, and we set the stop words up to English. Max df equals 0.5 and min df equals 0.01. And then so we insert this code here, and what this code here does is it converts it to Tfidf, and you can see that we got a list of 5 words that it's converted it to. Now we check our shape. So you can see your shape. You've got 908 columns for Xtrain Tfidf, Xval Tfidf, and Xtest Tfidf. And we've got 6 columns for the Ytrain and Yval. Now we select our model, and I decided that we had to use multi-output classifier, and the reason why we have to use multi-output classifier is because you have more than one column for your target. And then I decided to use logistic regression. I went onto ChatGPT and asked what was the best model to use for natural language processing, and logistic regression was one of the models that they chose. And since I've had success with logistic regression in the past, I decided to go ahead and give it a try. So model equals multi-output classifier, brackets, logistic regression, brackets, multi-class equals multinomial, max iter equals 5,000, C equals 100, random state equals 42, dot fit Xtrain at Tfidf Ytrain, and then we print our score, which is 56%, which isn't great, but it's better than what I previously had gotten. And now what we do is we predict on our validation set, and when we predicted on our validation set, we only got 50% accuracy, which isn't great, but hey ho, we got something. So now what we do is we predict on the test set. So predictions equals model.predict x test Tfidf, and these are your predictions. It's an array of 60 columns of data. And now we prepare our submission, and this was a little bit tricky too. So in the submission, we insert IDS into column 0, and then we insert the predictions in column 1 to the very end. We convert submission to a CSV file, and then we read this CSV file, and you can see your submissions, which is 5,586 rows by 61 columns. So that's what Kaggle wanted to see, and that's what I submitted to Kaggle. It took me a long time to do it, and the reason why it took me a long time to do it is because it took a really long training time. It took a long time to process all those words using natural language processing, and then it took a long time to train and fit the data with logistic regression. And as I said, I'm number 6 out of 6 on the leaderboard, but at least I'm on the leaderboard. And I also made my notebook public, and nobody else made their notebook public. And the reason why that is because people who win competitions don't generally show their notebooks because they don't want people to know what they've done. But I show my notebooks. I show my notebook. So, although I haven't done very well, but I did get on the leaderboard. It accepted it. And maybe, who knows, maybe one day, if I think I'm going to win a competition, maybe I'll make my notebook private too. Who knows? But at the moment, there's no luck of me winning a competition. I think last week I did one, and whenever I did it, I was number 1 on the leaderboard, and I thought, oh, maybe I'll win this competition. But some other people went behind me, and did better than me, so I didn't win the competition, but who knows, who knows. And if I ever decide to enter a competition for money and I score really well on the leaderboard, maybe I'll make that private as well, who knows. But at the moment, I'm making my code public so everybody can see my code. So I'm going to go ahead and conclude this video because I've been talking for 20 minutes. And I hope that you got something out of this code review and were able to employ the techniques that I use to at least get on the leaderboard. So if you like my video, please like, subscribe, and share. I want to thank my subscribers for supporting my channel, and thank you so much for watching this video.